Welcome back to ChemOrgChem. Today we are going to continue our tributyltin hydride lesson in part 3. If you are new to this channel, don't forget to subscribe. Let's move in tributyltin hydride. So in our previous part 1 and part 2 video, we already seen that tributyltin hydride preparation, application as well as properties. In this video, we are going to see three more important applications such as reduction of alkenes and alkynes and deoxygenation of alcohol, that's called pattern McCambie reaction, and pattern decarboxylation. Let's see one by one. The first application is reduction of alkenes and alkynes. Tributyltin hydride is highly useful for reduction of alkenes. For example, when you take the acrylonitrile in the presence of tributyltin hydride ABN, which produce this corresponding reduced product. Let's see the mechanism. So initially, when you use tributyltin hydride ABN, which produce this corresponding tributyltin radical, if you are not sure how to generate this tributyltin radical, don't worry, you just watch our part 1 video, you will understand better how to generate tributyltin radical when you use tributyltin hydride and ABN. So this tributyltin radical readily attack the alkene in terminal position. So because of that, you will get the new carbon center radical here. This carbon center radical readily abstract the proton from tributyltin hydride, which produce this corresponding reduced product. Just like alkene, alkynes also undergo that similar type of reaction. For example, when you take this substrate, when you use tributyltin hydride ABN, which readily produce this corresponding Z alkene. This Z alkene readily isomerizes under this reaction condition, which produce E alkene product. If you want to stop up to this step, if you use some Lewis acid like titanium tetrachloride, so that restrict the isomerization reaction which produce this corresponding Z alkene product. Moving on, deoxygenation of alcohol, that's called pattern McCambie reaction. So this one of the free radical mediated deoxygenation reaction. According to this reaction, initially we need to convert alcohol into their corresponding thiocarbonyl derivative. Here you see this thiocarbonyl derivative when you treat tributyltin hydride ABN, which produces this corresponding hydrocarbon product. So this reaction is called a pattern McCambie reaction. So in this thiocarbonyl derivative, R1 can be either hydrogen, methyl, thiomethyl, phenyl, or O-phenyl or imidazolyl group also. So this is one of the very famous method to remove the hydroxy groups. Next, we moving on the mechanism, how this reaction works, we'll see. So when you use tributyltin hydride ABN, which readily generates the tributyltin radical, now you see this radical readily attack here, then followed by this one of the pi bond electron joined here, which makes new tin sulfur bond along with one carbon center radical. So now you see this one electron moves here, then followed by this carbon oxygen bond homolytically cleave, which produce new carbon center radical along with this tin based byproduct. So in fact, this formation of tin sulfur bond is a main driving force for this pattern McCambie reaction. So after the formation of this carbon center radical, which readily interact with tributyltin hydride and followed by abstraction of hydrogen, which produce this corresponding hydrocarbon product along with tributyltin radical. Let's see some of the example based on pattern McCambie reaction. So now you see this substrate containing one primary alcohol as well as secondary alcohol unit. When you use this reagent, which readily produce this corresponding thiocarbonyl derivative, now you treat with tributyltin hydride, which readily deoxygenated this place as well as this place, which produce this corresponding product. So this is the another example. Now you see this compound having secondary alcohol group. When you treat with sodium hydride and carbon disulfide and followed by methyl iodide, which readily produce these corresponding thiocarbonyl derivative, then followed by treatment of tributyltin hydride, which readily deoxygenated this particular position, which produce this corresponding product. So this is the another example containing imidazolyl, thioimidazolyl group when you use tributyltin hydride IBN, which readily deoxygenated this position, which produce this corresponding product. So next we moving on pattern decarboxylation. Their mechanism is just similar to pattern McCombie reaction. So here also the thiocarbonyl derivative when you treat with tributyltin hydride AIBN, which produce this corresponding hydrocarbon product. Here the thiocarbonyl derivative comes from the corresponding carboxylic acid compounds. So this also radical mediated reaction. So initially we should see how to make these corresponding thiocarbonyl derivatives from carboxylic acid. When you take the carboxylic acid derivative, when you treat with either thionyl chloride or oxalyl chloride, which produce this corresponding acid chloride, which react with this compound, which produce this corresponding thiocarbonyl compound. Or another way, when you take the carboxylic acid, use coupling reagents such as DCC and followed by this compound which produce this corresponding thiocarbonyl derivative. So let's see the mechanism, how this reaction occurred. So initially this thiocarbonyl derivative just react like the Spartan McCombie reaction. So when you use tributyltin hydride AIVN, which readily produce tributyltin radical. So now you see here also the formation of tin sulfur bond is the main driving force for this reaction. So here you see this radical attacks here, then followed by one of pi electron attacks here. That makes the formation of new tin sulfur bond along with here you see one of the electrons shifted here, then followed by oxygen nitrogen bond homolytically cleave. The one of electron comes here, which readily produce new oxygen center radical and followed by this tin based byproduct. So now you look this oxygen center radical. So now this electrons moves here, then followed by this carbonyl carbon bond homolytically cleave to produce new R center radical, then followed by elimination of carbon dioxide gas. So this R center radical, which readily interact with tributyltin hydride, which readily produce the corresponding hydrocarbon product along with tributyltin radical. Let's see some of the examples for here. So now you see, so this one is carboxylic acid. When you treat with oxalyl chloride, which produce corresponding acid chloride, then followed by treatment of this sodium salt of thiocarbonyl derivative, which produce this corresponding thiocarbonyl compound, then followed by treatment of tributyltin hydride AIBN, which produce this corresponding hydrocarbon product. So this is the another example. So here you see having carboxylic acid, when you treat with oxalyl chloride and followed by the same type of derivative which produce this corresponding hydrocarbon product. So in this video, we covered 3 important applications of tributyltin hydride reagent. I hope this video has expanded your knowledge on tributyltin hydride reagent. So here are some of the practice problems. When you get the free time, you just give it a try. So if you like this video, like, share, comment, as well as subscribe for more engaging content. Until next time, bye bye.